Hello everyone, welcome to another video of Hack the Box Sherlock's. So in this video, I'll be walking you through Sherlock called Ghost Thread, which was a part of a CTF called Operation Blackout 2025. So this will be the first Sherlock of this series that I'll be walking you through. So let's get started without wasting further time. Uh, so we'll just understand the scenario, which is again a very generic scenario, an imaginary one, where a byte doctor suspects like there is a process injection technique that attacker has used, and we have been provided with some Win32 API logs for us to determine which process injection technique was used, and also determine which the legitimate Windows process was targeted during the attack. So this is easy Sherlock. So we only have like a couple of tasks to answer in this Sherlock. I have already downloaded all the artifacts here, and it comes with an instruction of how you can open up these files using tools. I64 is nothing but an IDA, a file for IDA Pro, where you can just open it up and analyze the binary. Instead of so here the Instead of providing the binary, the author has just provided the I64 of IDA Pro. So the APMX64, as you guys know, most of you guys might be familiar with. It's a file which you can open up using API Monitor and analyze all the API calls. Um, okay, so we will get started with the first task, the which is what process injection technique did the attacker use? So I have already opened up IDA, and I'll open up the I64 file. And let's see what we have in this file. Okay, so again, IDA opens up a lot of stuff from binary, like you have a couple of tabs. So as soon as we open up this I64, or or anything, like when we start doing our reverse engineering stuff, we'll always see what are the exports from the binary, and as soon as we click on the exports, we have a main entry and an interesting name called TLS callback. So I'll see, as it looks very interesting. I mean, like, you can just double click this and see that there is a TLS callback being utilized in the binary, and we have keywords like injection, and we also have message box, and within the same TLS callback, we have the open process, and yeah, it looks like injection to me. I mean, so we also have, yeah, like injection, open process. It opens up, and then looks for. Um, you can just see what's available here. Uh, so as like as soon as we double click on the injection part, we see that there is like something like process found injection, and this definitely looks like injection technique that the attacker is utilizing. But this injection is very different from the rest of them, as we saw in the exports that the TLS callbacks are being utilized. TLS callbacks are nothing but these callbacks are executed before the main executes, so that um, to avoid detections from the endpoint security systems. It's basically, let's say, EDR hooks all the DLL, hooks its DLL into any new process that is being executed in a system. So here, if you use TLS callback as it is being executed before the main executes, the DLL never gets hooked, and the attacker would be able to run the malicious code easily. Uh, yeah, so the answer for this first question is pretty straightforward. It's TLS. TLS is nothing but thread local storage. We'll submit the answer. Yeah, perfect. So we'll go ahead with the task two. Which Win32 API was used to take snapshots of all processes and threads on the system? For this, we will open up the API monitor, um, and open the APMX64 file. We'll wait for it to load all the files. Not sure why it's so slow today, but anyways, we can wait. Damn, no wonder why it took so much time. But yeah, we so everything has been loaded here. Like all the modules have been loaded. We will open up the APMX64 file, and just like every time, we will. I mean, whenever we click on the process, all the modules, we see all the API calls of all the modules, DLLs here. So we will just concentrate on what was executed from the inject.exe. Okay, so the second question is, okay, yeah, which Win32 API was used to take snapshots? So, I mean, whenever we see like process injection being created, uh, it's usually like the attacker or a malware developer or anyone who wants to develop a process injection code in C will always you utilize this Win32 API called create tool help 32 snapshot, and using this, we can just look up for any processes that that we want to search in a system, and then extract the process ID from it. So as you can see, like the inject.exe is for utilizing create tool help 32 snapshot, and then it calls process 32 first, and then compares notepad.exe. uh, Here it's also very clear that attacker is trying to search for notepad.exe and then comparing it with all the processes running in the system. So the answer for this should be, um, the create tool help 32 snapshot, as it is responsible for getting the snapshots for the processes in the system. We'll just submit this. Yeah. Which process is the attacker's binary attempting to locate? Yeah, it's pretty clear here that the attacker is trying to look for notepad 32, no, sorry, notepad.exe. Um, and we'll just scroll down just to confirm if it's the one. Okay, so yeah, on on this line here we see, as soon as the binary or the process, the inject.exe process finds notepad.exe, it ends the search and um, returns back to the function which says process found. So the answer has to be notepad.exe. Yes. What is the process ID of the identified process? So here we just have to follow how binary executed all the Win32 APIs. As soon as the process is found, it calls open process, and here open process. In order to open any process, it has to have the process ID, and it has three arguments. And the third arguments, as you can see, is process ID and the process ID of notepad.exe at the time of execution was 1622.4. Yes. Okay. So the task 5. What is the size of the shellcode? Okay. For this, we'll again the follow the execution, the flow, and here we see something called as virtual alloc ex, which is basically being utilized to allocate some memory address of a particular size, like here a particular size, as in the size of shellcode that will be injected into the notepad.exe. So here we have like five arguments, and the one that gives us the size that is being used, I mean being allocated, uh, is 511, and we can also confirm this here, the 511, and this is all the shellcode that was being written inside the notepad.exe. So yeah, the answer for that should be 511. Yes. And the task 6, which Win32 API was used to execute the injected payload in the identified process? Uh, okay, so the right process memory allocates, sorry, the virtual allocate ex alloc ex just allocates memory, and this will write uh, the shellcode, and the one that is being actually used to execute in this process injection technique is create remote thread. Yeah. Let's submit the answer. Yeah. So the last question for this Sherlock is the injection method used by the attacker executes before the main function is called. Which Win32 API is responsible for terminating? So yeah, so as in the first question, like we identified that attacker was using TLS callback in order to end the execution before the main runs. Attacker or uh, anyone who's trying to uh, develop this kind of payload or this kind of technique has to execute exit process in the TLS callback function. We can also confirm this in our IDA Pro. Yeah. So as you can see, when the injection and all the things are done, we are calling exit process, and the main never gets executed. Uh, so we'll submit the answer. Yes. That's it, guys. This was the first Sherlock, an easy one, to be honest. Yeah. So the main goal here was to teach the TLS callback injection, introduce this injection technique to the players, and uh, just help them understand how this works, and also start thinking like how defenders can actually detect these kind of injection technique. And I know it's very like challenging to detect such, because the main never gets executed, and uh, the the security solutions cannot hook uh, their DLLs to monitor what's happening in the binary. Uh, so I'll be sharing an interesting detection technique in the future, a research that I am still doing in my own time. So stay tuned, subscribe, and uh, see you guys in the next Sherlock of this series. Thank you for watching.